we're asked to find the result if we combine the following vectors. And so I like to start by drawing just a picture of the random vectors. So I'm going to give myself a horizontal plane to start on. From here, I'll draw my first vector, vector L, which is 10 feet. And that is, what, 38 degrees off the horizontal. And from there, from that tip, I'm going to go ahead and add on vector M, which goes 20 feet. And that's vector M. And let's give ourselves a horizontal or imaginary horizontal line to give us an angle to draw off of that. And we'll call that, what, 23 degrees. And the question is, what would be this result vector here? And we'll call it just vector, well, let's keep our alphabet going, LMN, vector N. So to figure this out, I need to find my x and y components for both of my vectors over here. So we'll use L of x, and we get a different color here, we'll use L of y. And we also need to find our M of x, so that goes straight down. Or this is our M of y, I'm sorry. And we need our M of x, our x component for M. And we're going to use these components to find our y and x components for n, so then we can solve for n itself. So we have n of y and n of x. And we can say n of x will equal L of x plus M of x. And of course, n of y will equal L of y plus M of y. And then we can use these values to find the total n and the angle as well. But from there, let's go ahead and solve for these individual x and y components. So let's start with SOHCAHTOA. That's what we need to find our individual values. We need SOHCAHTOA. So let's start by finding L of x. Well, L of x, to find that, we are going to use our angle, so it's going to be one of these values, sine, cosine, or tangent. And it's adjacent to our angle, and we have the hypotenuse, so that's adjacent to hypotenuse. That is cosine. So we're going to use the cosine of our angle. Cosine of 38 degrees equals, well, L of x divided by our hypotenuse, which is 10. And so we can rewrite this as L of x equals 10 times the cosine of 38, because we just multiply by 10 on both sides. And then we can figure it out by typing it in our calculator. So we take 10 times the cosine of 38. And we'll get L of x equals, what, 7.9? 7.9. So I'll go ahead and say 7.9 feet. And I'll even add a positive sign there since it's going to the right. Or I could just recognize that it's going to the right and know that that is a positive x vector. But to solve for L of y, we'll do the exact same thing. We will say, well, L of y, well, what are we using? Well, L of y, that's the opposite to our angle. We still know our hypotenuse, or we could use tangent and use our opposite and adjacent, either or, but I'm going to go ahead and use the opposite. So sine is opposite over hypotenuse. Sine of 38 equals L of y divided by 10, which is saying, well, we multiply by 10 on both sides, and we cancel it out on the right, and we have on the left, we have L of y equals 10 times the sine of 38. And we can type that in our calculator. So we say 10 times the sine of 38. And what do we get? We get 6.2 feet. So this L of y is 6.2 feet. And again, that's positive since it's going upwards. And so let's go ahead and find M of y now. Let's move on to this triangle. Well, M of y, well, that's going to be, well, let's look at it. The angle is down here, and it's adjacent to it. And we know the hypotenuse, well, adjacent and hypotenuse would just be cosine again. So it's the cosine of our angle, which is 23 degrees. That is equal to, well, M of y divided by the hypotenuse, which in this case is 20 feet. And we can rewrite that formula by multiplying by 20 on both sides. It's M of y equals 20 times the cosine of 23. And we type that into our handy dandy calculator. So we say 20 times the cosine of 23, and we will get our angle is, or our distance, I'm sorry, is 18.4 feet. So we can write that here, equals 18.4, and let me go ahead and move it over to the side a little bit, 18.4 feet. And the reason why I moved it over to the side was so I could put a negative here, since it's going downwards. Downward is a negative y component. And of course, we got to find our last component, which was m of x. Well, m of x would be, well, that's the opposite to our angle, and then we know the hypotenuse, so we'll say sine of angle 23. Well, that's equal to, and I'm running out of room down here, is equal to m of x divided by 20. And we can multiply by 20 on both sides and cancel it out on the right, and so we get m of x equals 20 times the sine of 23. And if you're starting to notice a pattern, that's a good thing, because this is all basically the exact same thing. And so we just say, or just following the same rules over and over again. So we type in 20 times the sine of 23. And what we get is, what, 7.8? 7.8 feet equals 7.8 feet. And it's important to note that this is positive because it's going to the right. Going to the right is a positive x component. And so now we can go ahead and find n of x and n of y just by adding up these values. So n of x will be L of x. We said L of x was 7.9 feet. And we can add that to whatever m of x was. Well, m of x was, we just said, was 7.8 feet. So we add those up. 7 plus 7 is 14. 9, or 0.9 plus 0.9, or 0.8 is what? 1.7, so 15.7 feet. And then the other one, well, that would be what? L of y was 6.2 feet, so positive 6.2 feet. And then we say minus, and this minus is very important. And we're subtracting 18.4 feet. And I'll go ahead and use my calculator to figure this one out, so we'll move this. But we'll just type it in. What's 6.2 minus 18.4? And we get a big old negative 12.2. You might say, well, what does that mean, Mr. Anderson? What does it mean if we get a negative vector? Well, it means if it's a negative y vector, it means it's going downwards, which it is. This is going down 12.2, or it is going down, so we already knew it was negative. So it turns out math always works, whether you're drawing a picture or you're calculating it out. Who knew? But we have n of x as well. N of x was 15.7 to the right. So with that, we can calculate both our direction and our magnitude. So our direction will be off the y-axis, so from the y-axis. And it's going, you can notice that it might, or you might notice that it's going sort of in this direction from the y-axis, which is a counterclockwise motion. And this is the negative y-axis, by the way. Let's go ahead and calculate the value. Well, we got our opposite angle and our adjacent angle. Let me get rid of those little dots that I just made for myself. Well, that's opposite and adjacent. That's tangent. So we'll use tangent to figure it out. We use tangent, and since we're looking for the angle, it'll be the inverse tangent of opposite over adjacent. Well, the opposite is 15.7, and the adjacent is 12.2. And you might say, well, do we need to worry about the positives and negatives? And the answer is no, it's not going to affect your answer. The positive and negatives just help you with the direction when you're writing out down and to the right or counterclockwise from the negative y-axis. But it won't change your values like your angle or your magnitude. So we go ahead and figure this out by typing it in. We go to second tangent of 15.7 divided by, what is that, 12.2?
And we'll get an angle of 52.2 degrees from the negative y-axis.
And to find our magnitude, we'll just do a squared plus b squared equals c squared. So let me go ahead and label this as a squared, and I'll label this, or not a squared, yeah. And then this one will be b squared. And then, of course, in vector will be c squared, or, well, it's not really squared, but you get the idea. And so I'll say vector in equals basically 12.2 squared plus 15.7 squared. I should say that it equals the square root of this. So we'll say, what is the square root of 12.2 squared plus 15.7 squared? What is that? Well, we get a total value of about 19.9 feet. And so we know our magnitude and we know our direction.
52.2 degrees counterclockwise from the negative y-axis.